In problem 14, we're given 10 measurements. We're asked eventually to find the standard deviation compared to the range, but where they begin is asking us to find the mean. So we need to add everything together. 7 plus 4 plus 4 plus 7 plus 2 plus 3 plus 6 plus 7 plus 2 plus 5. And we need to take it all and divide it by 10. When I put it into my calculator, 7 plus 4 plus 4 plus 7 plus 2 plus 3 plus 6 plus 7 plus 2 plus 5 gives me a total of 47. That 47 is then divided by 10 to give me 4.7 as the mean. Now that I have the mean, I need to find the squared distances from each of the data points to the mean. So the first is 7. I'm going to subtract 4.7 from it and square it. I see that 7 occurs 1, 2, 3 times in the data set, so really I'm going to do this 3 times. Then I'm going to do 4 minus 4.7, square the result, and in this case, I'm going to do it twice. Then I'm going to do 2 minus 4.7, square the result. Again, in this case, I do it twice. Then I see 3 minus 4.7, square the result. I only see this occurring 1 time because there's only 1 3 in my list. Same thing for 6, and same thing for 5. So I put this into my calculator. When I do 7 minus 4.7 quantity squared, my calculator tells me that that's 5.29. I'm then going to multiply that by 3. That gives me 15.87. When I go ahead and do it for 4 minus 4.7 quantity squared gives me 0.49. I'm going to multiply that by 2 and get 0.98. When I do 2 minus 4.7 squared, I get 7.29. Again, I'm going to multiply that by 2 because there were 2 2's in our data set. So when I do 7.29 times 2, I get 14.58. Each of the next ones is only done once, so 3 minus 4.7 squared gives me 2.89. When I do 6 minus 4.7 squared, I get 1.69. And finally, when I do 5 minus 4.7 squared, I get 0.09. My goal is now to add all these together, so I'm doing 15.87 plus 0.98 plus 14.58 plus 2.89 plus 1.69 plus 0.09. All of that totals up to 36.1. Again, that represents the sum of the squares, which is the top of my variance calculation. To now get the variance, I need to take that total sum and divide it by n minus 1. So I'm going to take 36.1 divided by 10 minus 1, or 9. That gives me 36.1 divided by 9, which is 4.0111. If I then take the square root of that to go from the variance to the standard deviation, I get that the square root of 4.011 equals 2.003. So I'm going to put as my standard deviation 2.003. Range is super easy. It's just largest minus smallest. Largest number I see is 7. Minus smallest number I see is 2. That's why the range equals 5. The range is how many standard deviations. What this really asks me is to take my 5, that's my range, divided by my standard deviation, 2.003. When I do that in my calculator, 5 divided by 2.003 gives me 2.496. Here it tells me to round to 2 decimal places, so it becomes 2.5. I'm sorry, 1 decimal place. So it becomes 2.5. Question 15 tells me distributions of measurements is relatively mound-shaped. I'm going to underline that relatively mound-shaped because really that's going to let me pick a column. Mound shape means that I'm in the empirical rule column, which if you're following along with what it was in the PowerPoint, would be the left-hand column. What I now need to know is based on the mean of 60 and standard deviation of 12, how many standard deviations did I move to the left and the right? So I'm going to take the two between numbers, 48 and 72. I'm going to do 48 minus the mean of 60 to get negative 12. I'm going to do 72 minus the mean of 60 to get positive 12. That tells me the raw distance we moved from our original starting point at the mean is 12 in each direction. But I really want to know how many standard deviations is that. Since the standard deviation is 12, when we divide each of these by 12, we get negative 1 and positive 1. That tells me that I went plus or minus 1 standard deviation. The mound shape tells me that I'm in the first column, so this should point me to the proportion 0.68. In number 16, it says a distribution of measurements has a mean of 65 and a standard deviation of 3. It also tells me that I know nothing else. When I don't know that it's mound shape, when I know nothing else about the distribution, I need to use my second column, which is Chebychev's rule. So now that I know I'm in my second column, I need to figure out how many standard deviations I've gone. So I take the two between numbers, 56 and 74. I subtract from them the mean. In this case, I was given the mean of 65. This gives me negative 9 and positive 9. That tells me the raw distance I moved from the mean, but I want it in terms of how many standard deviations I moved. So I'm going to divide it by the given standard deviation, in this case 3. Negative 9 divided by 3 gives me negative 3. 9 divided by 3 gives me 3. That's how I know I went plus or minus 3 standard deviations. If I line up the second column that I know nothing else about the distribution with the third row that it's 3 standard deviations, that should point me to a proportion of 0.89.